Hello, everybody. Well, happy July 4th. Happy Independence Day. Uh, what kind of drink should I have now? Sure. Yeah, happy Independence Day. Um, yes, today I worked at home. This morning. What time is it? I don't know. Maybe, what, 10 o'clock? 11 o'clock in the morning? So, I worked for at home couple of hours, then I fell asleep, and then I woke up and I worked another couple of hours, and then now it's time to take a break because I gotta get back to work too. I mean, at home, okay, in my house. After this recording, maybe I eat lunch and maybe I take a nap, and yeah, I still need to do some work. Okay, so some July 4th, I guess. But yeah, where I work, we got some deadlines, so yeah. Well, it is what it is. I have no complaint. So, we'll get back to mathematics, okay? Soon. I don't know when, but soon. It's coming, okay? So, it's forthcoming. Let's talk about something else. So, I have no tattoos, okay? And there will not be an occasion where some employers refuse to hire me or fire me just because I have no tattoos. And also, I'm fit. I'm toned. Okay, I got some small muscle, you know, not much, but small muscle. I'm very toned, slender, fit man, and I eat healthy. No employer will fire me or decide not to hire me just because I'm fit and I look presentable. Okay, that just doesn't happen. And also, I'm straight. I'm not gay, I'm straight. No employer will refuse to hire me or fire me just because I'm straight. But if you're gay, if you are obese, or if you're tattooed and pierced, then you may subject to I wouldn't call it discrimination, but you may subject to some limited opportunity, job opportunity. Yes, just because you're gay, just because you're obese, just because you're tattooed and pierced. Why? Because everybody likes this clean skin, no tattoos, no piercing. Everybody loves that, and there are many people who hate people like me, tattooed, pierced, obese look or gay look. There's so many people who hate that shit, like me. Okay, so if you happen to be gay, tattooed, pierced, uh, you're limiting your job opportunity because there are, if you don't have any of that, obesity, tattoo, gayism, piercism, if you don't have marijuanaism, okay, if you don't have that, then people will like you. There's more chance that you'll be liked by more people and more employment opportunity. Okay, but if you're tattooed, pierced, smoke marijuana, obese, you gay, lesbian, transgender, that will limit your job opportunity tremendously. Okay, so whether that's discriminatory or not, whether you like it or not, whether all those ideologies are good or bad, or neutral, or whatever, the reality is it will limit your job opportunity, your career. Okay, so that's the practical reason to not do those things. Okay. Yeah. Anyway, so I talked to my folks in South Korea on the phone, and my mom told me, because I sent them my picture, my selfies, bathroom selfies. My mom said my mom has very good sense of humor. She's telling me, son, you're not a scientist, so you don't have to try to look like Einstein. You're not a scientist. You're not a philosopher, so you don't have to try to look like a philosopher. and you're not a comedian, you're not a comedic actor, so you don't have to look like one. Okay, so yeah, go to barber shop and get some haircut. That's rough translation to English because she speaks Korean now. I was like, yes, mom, and I think I will do it. Yeah, I think I'd go to barber shop and tell the barber, yeah, just side and back, just maybe 2 to 3 inches, but don't touch the top and front hair because I need them to cover up my bald spot, you know. So if they get too long, yeah, I can cut myself. But yeah, side and back, yeah, 2 to 3 inches. Just cut 2 to 3 inches, side just side and back. I think I'll do that. Okay. Because just to show my parents that I know how to obey. Okay. Yeah. And she can be very convincing. My mom, she can be very convincing. She's like, yeah, just as an experiment, you know, yeah, just go to our shop, have a haircut, and see what your bosses, your colleagues have to say. Yeah, just as an experiment, you know. So she's very convincing. So I was sold. Okay, so yeah, I go to barber shop at some point soon. Okay, yeah. uh, yeah. So today I probably end up working like 8 hours, like because I wake up very early in the morning. So why? I'm just what morning bird kind of early bird kind of person. Even if it's Saturday and Sunday, yeah, most of times I wake up just like any regular days. 5 o'clock, 6 o'clock, typically. Okay, typically. So this morning I woke up and I did work for like about 2 hours, I guess, and fell asleep. Woke up another 2 hours, and I probably have to do 2 more rounds of that to get this particular assignment done. I mean, my bosses they didn't assign me to work at home today, holiday, but I volunteered to do so because uh, it need to get done, you know. So yeah. Hey, are we ready to talk about mathematics, or you want to talk about something else? Um, yeah, let's talk more about this. Okay, education. So my home is it's decent. I mean, the tidiness level is decent. Okay. Uh, the tidiness level is not like pitch perfect, but things are in their own place. I put things in place. Not it's not like everything is everywhere. No, no. But is it like really like organized and clean and squeaky clean? No, no. It's kind of halfway in the middle. Okay. And that's just the way I grew up. Okay, it's not too tidy, not too untidy. There's some order in there. Okay, that kind of stuff. Okay, so you know, my mom, she is very extraordinary lady. She's very beautiful, and also she told us how to be beautiful. So it's about facial expression. Okay, it's also some Korean actors on television. They told us too. Yeah, make it bright, brighten up your face. You know, don't like no, no. You know, bright. Put some light. be like star, like light bulb. Yeah, have some bright facial expression, and actually it brightens your mind too. Okay. Uh, your mood affect your facial expression also, but it's two-way street. Your facial expression affects your mood as well. Your personality affects how you look on your complexion, your face. But the way you express, the way you do your face also affect your personality too. It's two-way street. Okay, uh, so my mom, Korean actors, they all taught me this. Also Jim Carrey, okay, American Canadian American actor. Yeah, also my teachers, elementary school, high school teachers, okay, in back in South Korea, and also my American friends, okay, because Americans have very colorful facial expression, right? So yeah, I learned all these wonderful techniques. Yeah, facial expression, this facial muscle exercise, like when I'm driving my car, like ooh, facial expression, this facial muscle exercise. I do that. I did that when I was an actor. I mean, actor wannabe, in in Los Angeles, California. When I tried to become an actor, before I go to audition, I would do, yeah, this facial expression routine, facial muscle exercise. Okay, and yeah, that's important. Okay, and also your hair is important. You know, you may laugh at my hair, but at least I put some time, effort to it. Monday through Friday in the morning. After I get out of my bath, because I take a bath. I don't take shower. I take a bath, full bath, every Monday to Friday morning. Okay, and facial massage, exfoliation, full body exfoliation. It's Korean bathing. Okay, we like scrape with our gently scrape with our fingernails. Okay, so yeah, exfoliation. Okay, bathtub. Okay, including face. Gently, not like not like that, but gentle exfoliation with fingernails. Okay, full body, every surface of your body, every square inch of your body. Tongue, and in the inner lining of mouth, like back of the mouth, like with my finger. Yeah, I clean thoroughly Monday to Friday morning. Okay, and then so yeah, also clothings. Okay, yeah, I go to you know thrift thrifty shops. They're all used clothing, thrifty shops, and yeah, okay. Exercise, diet, of course, right? Yeah, it's important to look good. It makes you a happier person. Okay, so it's important. Okay, so I grew up in that kind of environment. My parents. Okay, and the importance of looking good, taking care of your appearance. Okay, and but many of you didn't have that kind of blessing. Perhaps your parents, they just don't give a fuck, right? They're obese, they stink, and your parents, they put everything everywhere, and like you live like some pigs. Maybe that's how you grow up. Maybe that's why you are just like your parents. It sucks to be you. I'm sorry. You are really screwed. Okay, because just because you met very bad parents. So yeah, sucks to be you, but but you met me here. If you're here with me, okay. So lucky you. Why? Because I'm gonna change you. I'm gonna exercise you. Okay, so you inherited the Satan of ugliness from your parents. Okay, but I'm gonna exorcise that devil out of you. Okay, so that's the whole point of humanology. It's about human improvement, exorcism. Okay, so that's why we are here. Okay, it's just like it's very Jesusian. Okay, Jesus came to earth to call the sinners, not the righteous. Okay, that's what Jesus said. We we want to be like him, except the crucifixion. We don't do crucifixion. Okay, that's only Jesus. We don't do that shit. So yeah, we want to be exorcists just like Jesus. Okay, so then what do you need? Easy discipline. Do the hard right, not easy wrong. Just like I learned in U.S. Army by sergeants. Yeah, tidy up. I mean, it takes discipline to clean up your house, but you should do it. Okay, put things in the right place. Okay, vacuum your floor, carpet once in a while. Yeah, it takes 3 months, tremendous discipline to do that. Also, wash your clothing, do the laundry, wash your linen, laundry your linen, your bed sheet, pillowcase, blankets. That's what I did yesterday. Did I want to do it? Not really. But I do so because it's the right thing to do. Otherwise, it will smell bad. And fungus and germs, bugs. You don't want that in your house, trust me. Okay, so yeah. Wash, smell nice, wash. Monday through Friday. Preferably in the morning. Okay. Yeah. Take a shower, take a bath. Okay. And exercise and diet. Okay. Diet and exercise, well, that's the only way. There's no other way. Yeah, eat healthy, vegetables, fruits, nuts, noodles. Carbs are not bad. And also sodium is not bad. Okay. Salt, they're essential element of life. Carbs, again, essential element of life. But sugar is bad, fat is bad. Fat and sugar, those are the what makes you fat. Sugar and fat. Okay? So don't do sugar and fat, okay? Just do noodles, wheat, bread, multigrain bread, rice, beans, vegetables, fruits, nuts, but nothing like cakes, pies, pizza, cheese, fried stuff. That's like should be like once a year, maybe once a quarter. Okay, but not like on a weekly basis. Okay. Yeah, exercise. All right. So, uh, there are weak people and strong people, right? As adults, what makes that difference? Yeah, it's from their parents. It's about discipline. Because if your parents are very disciplined people like mine, then your parents will impose you many rules. Don't do this, don't do that, do that, do this. There'll be a lot more rules. Like, for example, put food in the fridge. When you drink milk, use the cup. Don't drink off of the milk bottle like a baby. Don't do that. Use the cup. And after you use a cup, wash it. So many rules. After you wash it, put your cup in your cabinet, not on the floor or on top of refrigerator. No, put your cup in the cabinet. Oh, how about those vodka cups? Ah, well, they're plastic cups, and that's the right place. I don't put vodka cups everywhere. No, I put over there or over there. After the recording, I pick up all the cups because right now it's right here next to the computer. But after the recording, I put back these cups either over there or over there. Okay. Why? Because we have earthquakes in Alaska, so it can get spilled over and ruin my computer. Okay. So I have to put it back away from the computer. Okay. I always do that. Always. Okay. So like it's about rules, ethical life, moralistic life. It's about more and more rules. Humanological ethics. Don't do tattoo. Don't do piercing. Don't do marijuana. And don't do gay shit. Okay, and don't do ultra interracialism. Okay, many rules. Okay, how to be fit. Again, more rules. How to be healthy. Rules. Don't eat cheese. Do not eat fried food. Don't use oil when you cook. Don't eat candies. Don't eat pies. Don't eat ice cream. Don't eat chips. Don't eat cookies. Do not eat many rules. Okay. Eat fruit. Eat fruits, nuts. Eat vegetables. And exercise every Monday to Friday. Weightlifting or running or whatever. Rules and rules and rules. Okay, so but if you're a woman, young woman, you should not make too much muscle because you will look like a freaking monster, lesbian, transgender shit. Again, more rules, right? If you're a young woman, you should not make too much big muscle. If you're a woman of any age, you should not make too much muscle because it doesn't look good on women. Because you don't want to look like a man, okay? But old women, they do need to do some weightlifting because old men too. Because old people, they start to lose muscle weight and bone weight, and weightlifting is very preventative of that. Okay. I mean, even if you're a young woman, you can do lightweight, but women of any age should not make too big of a muscle because that doesn't look good. Okay, so, but yeah, for women, light weightlifting is healthy, something light. Okay, but everybody should do cardio. Okay, and you should learn martial art. You should learn dancing. Those two things, martial art and dancing, that's mandatory for everyone. Okay, and if you're an adult, you should not be playing video games. Okay, because that's fucking retarded. Okay, so waste of time. And you should work. You should have a job. You should never retire. All right, you should have a job. Find something to do and produce something that sells. Okay, and you should work. You should also study. Okay, and you should also teach. Okay, if you're an adult. Look what I'm doing. I'm teaching and learning, right? Yeah, you should study, you should teach, and you should also study foreign languages. Okay, you should also study science and history. Okay, freedom. Well, you don't have any freedom. When I'm the president in 2021 January, you're not gonna have any freedom. No. Okay. Yes, I will be the supreme dictator of the United States. I will be the Mr. Kim Jong Un of the United States. Okay, hey, look at me. I'm Korean, right? So what else do you expect? Well, let's take a break before I totally go crazy, huh? And then we'll talk about copium channel resistance. Okay. Yeah. Yeah, mathematics we'll do later. Okay. We don't have to do it now. So we'll give some love to humanology. Okay. So yeah. Okay. So let's talk about humanology, copium channel theory, channel resistance theory. So there are two kinds of resistance. Um, no, positive resistance, negative resistance. That's kind of very confusing term. Okay, so uh, we'll just call it like there's ascension and descension, right? Uphill, downhill. Okay, so ascending resistance, okay, and descending resistance. That's how we're gonna call it, okay, because that's more intuitive. Uh, descending resistance, descending channel is like downhill, okay. It's kind of like negative resistance, okay. But that term is confusing because it positizes your copion, okay. You feel great when you go downhill, ski, snowboard, or you go to swimming pool, the slide, or when you go hiking downhill. It's a lot more easier and fun, exhilarating. If you go biking, yeah, downhill biking, easy ride, right? Kind of uphill. That's what causes you a lot of pain. So when your parents and your teachers educate you, when you do something wrong, what they do, they punish you. Well, at least they are supposed to, right? And you remember that painful moment, so you don't do that again. Okay, so that's they're building up this ascending resistance in that channel, so that you don't do it again, because you remember that painful experience of being punished. Okay, and what if you do something good? Then they build this descending resistance, this channel that's good conduct, good action. They reward you. Okay. In psychology, they call it what, negative reinforcement, positive reinforcement. But that's awkward. Okay, so yeah, they're not very good scientists. Okay, psychologists, psychiatrists. It's not their fault. It's just that God didn't give them any wisdom. Okay, so but He gave it to us, humanology. Okay, so it's not to our credit or to their discredit. Just like if you met bad parents, it's not your fault. You didn't choose your parents. I met good parents. I don't deserve any credit for that. Okay. So I'm sharing with you what I learned from my good parents, good teachers, good friends. If you didn't have any, yeah, take it from me. I'm sharing with you. Okay? So, uh, so yeah, that's the installation of ascending resistance or positive resistance. Maybe it's no better than psychology, okay? Negative, positive reinforcement. But psychologists too materialistic. They see people as some kind of machinery, because they claim they are scientists, and so. But humanology, we use a lot of science ourselves. But at the same time, we believe in religion, power of religion. Okay, that's the difference between psychology and humanology. Humanology equation is humanology is equal to religion plus science, science plus religion. Okay, uh, we believe in, we fully acknowledge the power of belief and faith and miracle, hope. Okay, we recommend people to have some nice religion. Okay. Okay, so I think now we are ready to get back to mathematics. So I don't know where to begin. So let's just grab some random whiteboard. Periodic study. Okay, so we grab this guy, and we're gonna, no questions asked. We just erase this shit. Okay, so throat got phlegmy. Ah, sorry about that. Yeah, before this recording started, I ran just around the blocks and I did pull-ups. Okay, so I didn't want to. Okay, it's holiday, right? So I didn't want to do that, but I forced myself to do it. Okay, and because I'm disciplined by my parents, my teachers, U.S. Army, my former bosses, current bosses. Yeah, I'm very well disciplined person. Okay, so I'm disciplining you. Okay, discipline is about pain, about tolerance of pain. Okay, when you lift weights, yeah. Do I want to run? Not always, but I do so Monday through Friday. And today's, yeah, what, Thursday, July 4th. Okay, it's a weekday, so I run anyway. Okay, it's about discipline. I say many things that offend you, right? That you have horrible parents and you are fat, you're obese, you're gay, you're tattooed, pierced. You... It's about infliction of pain, okay? That's what's gonna make you a better person, okay? So, humanology is fundamentally different from psychology, okay? So, because in psychology, psychiatry, oh, childhood trauma, child abuse, that's bad. We say no, pain is good, okay? As long as it doesn't injure you permanently. I mean, secular saying, yeah, what doesn't kill you makes you stronger. Yeah, this American secular wisdom, right? Common sense. Okay. Yeah. Periodicity, huh? Okay. Maybe I shouldn't have erased this. Okay. Well, but whatever. Whatever. And we don't need two erasers. So it's like periodicity, huh? Okay, so uh, we take it slow. Okay, so periodicity can be proven using the subset theorem. Okay, so like we are not gonna even do Euclidean steps now. We'll just do modular arithmetic, row algebra. Okay, so you set of positive numbers. Okay, using horizontal juxtaposition notation. We don't do curly bracket, comma. We don't do that shit. We just delimit by using empty space. Okay. I'm sorry. 0 plus. Okay. Non-negative integers. Natural numbers. Okay. Okay. Something like that. And this black is dying, so I'm gonna use this black. Hopefully it's strong enough. Now, 3m multiples of 3. Okay, 0, 3, 6, 9. Okay, 3m1 is all the numbers when it's divided by 3, the remainder is 1. You have one more, 3m2, right? Yes, this diagonal stripe. So there's periodicity here, okay? Okay. We should come up with a theorem to prove, okay, that has to do with periodicity, all right? Okay, well, what about 6m? You know, sure, yeah, we'll do 6m. Well, 3m is 3m, okay, multiples of 3, the same as 3m 0, okay, so 6m is equal to 0, 6, 12, right? And 6m 1, 1, 7, then 13, okay, yeah, we ran out of space, so, okay, so, but you got the idea, right? 3m 2 is 2, 8, then what? 14, okay? 6m3 is equal to 3, 9, and 15, okay? We just finished this picture, okay? 6m4 is equal to 4. You add 6, okay? So add 6, okay? So 16. Finally, 6m5, all the numbers when divided by 6, its remainder is 5, okay? So add 6 to this, 11, right? Add 6 again, 17, okay? Whew. And we picked 6 because 6 is a multiple of 3. Okay, that's why we picked 6. And as you can see, 6m is a subset of 3m. 0, 6, 12, okay? Yeah, you have 12 here. Okay, so 6m is a subset of 3m, okay? Meaning, if it's a multiple of 6, then it has to be a multiple of 3, okay? Furthermore, 6m1 is a subset of 3m1, okay? Six m2 is a subset of 3m2, okay? How about 6m3? Is a subset of 3m, okay? How about 6m4? That's subset of 3M1. How about 6M5? It's a subset of 3M2. Okay? And we can even do more. Okay? If we unionize, combine 6M and 6M3, 0, 3, 6, 9, 12, 15, that's 3M. Alright? Okay. If we combine 6M1 and 6M4, it becomes 3M1. Okay, so you have 1, 4, 7, 10, right? And 13. Okay, so 1, 4, 7, 10, 13. Okay, 16, blah blah blah, right? Now, one last time. 3M2 is 6M2 union 6M5. Okay, 2, 5, 8, 11. Okay, 2, 5, 8, 11, 14, 17, blah blah blah. Okay. What we are doing here is this. Okay, so 6 is 3 times 2, right? So we are decomposing each of these 3 sets into 2 subsets. That's what we're doing. Okay, so if we are discovering something in this modular arithmetic that we call raw algebra. Okay, like it's not cooked, it's like raw algebra. Okay, so it's bare naked, raw. It's not cooked, it's not clothed, just raw. The Greek letter rho, rho for remainder. Okay, so oh boy, yes, again it's like Alice's Wonderland. It's never-ending story, kind of. But that's fine. We are having fun. We are amateur mathematician, and I have given you enough hints to how to go about finding an algebraic formula for Fermat's, not Fermat, but for the prime numbers. Go ahead and do it. Okay. Yeah, I have given you the set theoretical expression for prime number function to find nth prime number probably like 2 months ago, and I have given you roadmap how to get there. Go ahead and find it before I do, by all means, and publish it and be famous, make money. Okay, yeah, by all means. Okay, so yeah, find that formula before I do. Why? Because I'm just enjoying this journey of learning things. So, but if you can get there before I do, yeah, do it. I encourage you to. Okay, but we are discovering new things again and again, time and again. So I just don't want to just dismiss this because I'm not very goal-oriented person. Maybe you are. Yeah, then go for it. Okay, yeah, find prime number function before I do. Okay, algebraic expression. Okay, so because I've given you plenty of hints already, roadmap, blueprint. Go find it. Okay, so but um, there's some things to explore here. Okay. 3M0 is 6M union 6M0 union 6M3. Okay, so we are decomposing this set into two sets, union of two sets. Okay, it's decomposition, like breaking down. 3M1 is 6M1 union 6M4. And we can generalize this, okay? So upstairs, the period is 3, right? You add 3, 3, 3. So period, that's the 3. Period is 3. What do we mean by this? Okay, periodicity is this. All right, so I have to use different color. Okay, so I don't think this orange or blue is very visible. Yeah, this orange is decent. So, uh, n row 3 is equal to 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0. Okay, so, and also, I'll write right here. N row 6 is 0, 1, 2, 3, 4, 5, and 0, 1, 2, 3, 4, 5. Okay, so if we divide this array, the sequence of natural numbers 1, 2, 3, 4, 5, 6, 7, if we divide each of those numbers by 3, the remainder is just 0, 1, 2, 0, 1, 2. Okay. If we divide all these natural numbers by 6, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. So, yeah, the divisor is also the period of these repeating cycles. Okay. So what's the subset theorem has anything to do with this periodicity? Yeah, we have to make connection. That'll be our next project, to find some connection, bridge between subset theorem and this periodicity. Okay, that's what we need to do today. Okay, I'm trying to come up with the simplest example to demonstrate the connection between subset theorem and periodicity. Okay, and I'm struggling. Okay, so let's take a break. So I'm kind of getting chilly. Okay, so I need to put some more clothing. Take 5. Okay, so. Oh boy. bad. Where's my glasses? Did I leave my glasses somewhere? All right. Yeah, somehow I'm kind of cold. Man, it's summer in Alaska. It's probably like what, 70 some degrees, whatever. Okay, periodic study. How do we connect periodic study and subset theorem? Maybe we should wait until we deal with the Euclidean step function, huh? Maybe. Oh. Well, it's not exactly connection, or maybe it is. Okay, so we know 6M0 and 6M3, they are subsets of, also they are disjoint subsets, meaning 6M0 and 6M3, they don't have any intersection. They are disjoint. Okay, there are two sets that does not intersect. There is no common element. That's what disjoint means in set theory. Okay, if A intersection B is equal to phi empty set, then set A and set B are disjoint. Okay, it's a relational function. It's a Boolean function. The disjoint function D, parenthesis A comma B, is either true or false. Okay, if the intersection is empty set, then it's true. They are disjoint. If they have some common elements, then it's not disjoint. So false, true or false, Boolean function. Okay. Okay. So they are disjoint and also they are complete subsets, meaning we call it disjointness and completeness. Okay. Completeness, it takes three variables. It's a Boolean function. Okay. Let's say input is A and B and C. Okay. If A union B is equal to C, then it's true. This completeness function, Boolean function, okay? But if A union B is not equal to C, is less than C, smaller than C, subset of C, then it's not complete. All right. Here, this 6M0 and 6M3, they are both joint, disjoint, and also complete. Because if you unionize 6M0 and 6M3, then it becomes 3M0. So it's complete. And also, these two sets are disjoint. Okay, so they're both complete and disjoint. All right. It's kind of like bijection, kind of like one-to-one correspondence. It's kind of like that. Okay, so, but a little bit different. Okay. You can write it down, yeah, make it into a theorem, whatever, okay. But I'm not going to, all right, because I have just too many things to do. Okay, we just give you as a homework assignment. Yeah, go ahead, formally define what is disjoint Boolean function, what is completeness Boolean function. Okay, I just told you what they are. Okay, so. Go write a textbook, mathematics journal paper. Go ahead and do it. Okay, so because I'm not going to. Okay, so I need some scarf and I need some blank sheet of whiteboard. Okay. Yeah, I'm such a temperature pussy, so look at me. Oh boy. Yeah, this guy. I think I will take a picture of this guy. Okay, it's kind of pretty. If I start erasing, I'll take a picture of this. Okay, so. Oh. I mean, it doesn't have too much mathematical significance because it's something very well known. It's something elementary, but I like the coloring, color combination, and this pattern. So. All right. Oh boy. Let's take a break from mathematics. I cannot tell you about this. So Wikipedia, right? I tried to publish in Wikipedia some of my mathematical theories, especially what pyramid numbers. I forgot what they are. I guess it's come from this combination binomial coefficient, but there's this girl like in her late 20s or early 30s. She's obese, tattooed, pierced. She's Hispanic. Okay, so my best guess is she's some kind of descendant of Maya and Aztec. This human sacrifice. She still have that in her gene. Third world savage mentality, very cruel and human sacrifice kind of third world savage mentality. Okay, because she's Hispanic. She's like, yeah. What do I mean? Do I have some third world savage mentality? Yeah. Right? Look at me. I'm. Don't you hear my accent? Yeah, I grew up as a child in Seoul, South Korea. I grew up as I got beat up a lot. Okay, so I do have some third world mentality like she does. Okay, I'm no, I don't know. Maybe she's born and raised in America, in Texas. Okay, uh, maybe she's more American than I am. Maybe she's more civilized than I am. But she definitely does have some this third world savage mentality in her because I felt like she's some kind of home invader, and my two kids were hiding underneath bed or some closet, and she went looking for my two kids and killed them underneath the bed and the closet because that's what she did. I published two articles in the Wikipedia, and she went long way to look for, search for my two articles, and she got rid of it. She got rid of them both. Okay, so, and she called me, she accused me, this Hispanic Texas girl in her, what, late 20s or early 30s. She's obese, tattooed, pierced. She's not ugly, she's just plain blank look. And she does these stupid things with these digital photos, like distortion of digital photos. She's very smart. Yeah, she's very humorous, good sense of humor. I can tell she's very intelligent, very smart, very talented. But she has this dark side. Okay, so she enjoyed getting rid of my Wikipedia articles, and she accused me of vandalizing Wikipedia. Okay, so that's like third world savagery, right? Very brutal and cruel, kind of. She was like enjoying doing that stuff, getting rid of. She didn't just do that to me. I guess she does this dirty job for Wikipedia. She does that to people like me, innocent contributors. We just wanted to share with the rest of the world what we discovered, and she's killing it, right? Like in New Testament, yeah, the what Herod, King Emperor Herod, whatever. Okay, he killed all these young boys and in Israel because he heard about Jesus. Okay, we have to kill Jesus, so let's kill all the young boys. Just like in Moses, King Moses, right? This Egyptian pharaoh decided to kill all the Jewish boys, and Moses got saved, right? Just like that. She's like just like that. She's killing all these Wikipedia articles by unknown establishment like me, by unknown people like me who don't have any credits. I don't have any PhD. I don't have any academic credits. I'm just unknown, but I still discover something, and all I wanted was to share this discovery with the rest of the world for the betterment of human knowledge. Okay, and this Hispanic girl, probably living in Texas somewhere, uh, she's killing all these babies, metaphysically speaking, not physically speaking, but metaphysically speaking. Okay, so that's how I felt. I felt like a mother whose house got invaded by this cruel third world Hispanic bitch, and she go through all these closets and underneath the bed, and she kills my children one by one. Okay, that's how I felt. Horrible. But don't worry, I copied and pasted my Wikipedia articles somewhere. Okay, I have it. Okay, so it's not dead. It got saved, just like Moses. Okay, yeah, baby Moses. Yeah, he got saved, right? Yeah. But yeah, I also have some third world savagery mentality, okay? Because maybe you've seen it, okay? So yeah, many times I'm brutal, like some developing country, third world, low level. I have that, okay? Because I grew up in third world, okay? Yeah. But I'm civilized, okay? So I commit no crimes, but sometimes I'm very cruel and brutal. You've seen me. But metaphysically speaking, okay, so but that girl, yeah, I forgive her. I pray. I have prayed many times to God. So please let her repent and become a better person because right now she's possessed by the devil, and I hope God, exorcise her and make her a better person because she's very talented, very smart, and we want her to use her good intelligence and talent for the good cause. Okay, we want her to be on our side, not on the other side, the devil. Okay, because that's where she is now. Okay, she's doing devil's job, suppressing development or advancement of knowledge. Okay, of course she's doing that on the behest of Wikipedia. So Wikipedia they need to change. Okay, so, because they are doing fine job, but they need to do better. Okay, so okay, yeah. I mean, no human organization is perfect, but yeah, I'm just pointing out what Wikipedia is doing wrong. Okay, so that they become better corporation. Okay, that's all. So take a picture, took a picture of this. So let's erase. Uh, completeness and disjointness. Okay, we just write it down. Okay, just for the record. Okay, and probably I should write down in my notebook. Okay, so disjoint. Okay, is a Boolean function of it takes two sets. Okay, that's the definition, right? So completeness. We better use kappa, right? Greek letter kappa, because we have C here. Okay. Okay. Now, 6M0 6M3 is 1. I'm sorry, disjoint of A and B. Okay, so kappa completeness of ABC. Okay, and also kappa 6M0, 6M3, and 3M0 is also 1. Okay, so these two guys are both disjoint and complete. Okay, so it's like they're tight. Okay, there's no gap in between, and they're not missing out anything. Okay, so okay, let's say you have C, set C. Okay, and you have set A, and you have set B. Okay, if they are not complete, that means You have some element here, some element here, and there's no common element, so they're disjoint. But completeness means uh, there's no elements in between, like here, somewhere. Okay, meaning, um, so this guy is equivalent to, another way of saying this guy is C minus A union B, okay, is empty set. Okay? C minus A union B, everything outside of A, everything outside of B, okay, is empty set. Okay, so uh, I will have to write this down in my notebook. Okay, so and then we'll take a break. Okay, so now I'm getting overheated a little bit, so I don't need this scarf anymore. Oh, blanket, slippers. I'm warmed up, man, by now, so. Yeah, I think it's important enough to at least formally express. Okay, this actually it's by definition. All right, so Boolean function. Okay, by definition. Okay. I love this mechanical pencil I just bought a week ago from my neighborhood grocery supermarket store. It's working so well. Oh, that's good. Okay, we'll take a break. Okay, so take five. Okay, we're back. Yeah, it was getting hot. Okay, so uh, I kind of got the feeling this joint and completeness function I think is significant enough that I have to write this down and put it in my notebook. Okay, so but that's that. Let's move on. All right, so yeah. So what happens when it's both disjoint and complete? I guess we can call it bijection or bijective relationship. Okay, bijection of a bijectiveness ABC. What disjoint defined as disjoint A and B, and the Boolean function, right? Completeness A, B, and C. Okay, this bijectiveness. Okay, we just call it that, and we'll leave it at that. I need to write this down. Okay, so. But no need to take a picture though. I'm sick and tired of taking pictures, dude. Oh boy. Okay. So, bijectiveness A, B, C. Defined as disjointness of A and B and completeness of A, B, C. Okay, so bijectiveness disjointness completeness. Okay, I think it's important. Okay, I mean, it feels like it's important. I don't know. Okay, whatever. It just feels like it's kind of important thing. Okay, so fundamental kind of like in function theory, one-on-one relationship, one-to-one function, onto bijection, whatever. Okay, kind of looks important. So what now? Uh, oh, I forgot one thing. Okay, so A and B has to be both subset of C. Okay, that's the condition. Okay, both A and B are subset of C, meaning A. Boy. A is a subset of C, and and B is a subset of C, which is equivalent to A union B is subset of C. Okay. You may think this will be have to be intersection, right? But it's not. So when this subset get distributed to like A subset C, B subset C, uh, the union actually flips to end. Okay, so why? I don't know. It just makes sense. Okay. this, yeah, and is more associated with this subset. I mean intersection, right? Union is more associated with or operator. Like what's or operator? Yeah, this. Okay. Or two of this, whatever. Which is, yeah, use two of this. Just one vertical bar is like A divide C. Like A is some divisor of C. Okay, so let me write this down. Okay. Yeah. So I wrote this down. We are doing a lot of set theory because it's something very powerful. Set theory, okay. So yeah, Georg Cantor, Herr Georg Cantor. Okay, so I think he was a Christian. Okay, I'm not sure he was a Jewish guy. Maybe he was a Jew. All right, but whatever. German Gypsy Jew. Okay. Oh boy. Okay. So we know. Let's use red. This red is strong enough. Yes, decent. We know 6m0 is a subset of 3m0. Multiples of 6 is 0, 6, 12. Multiples of 3, 0, 3, 6, 9, 12. Blah, 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 right? So yeah, it's a subset. And we know this. And second, we know this. 3 lowercase m0, which is an element of 3 uppercase m0. Okay, so rho 3 is equal to 0, right? And therefore, and then you have 3, the subset theorem. All right, you add them up. Okay, so therefore, 6 lowercase m rho 3 is also 0. Okay, so subset theorem, it's like what? Let's express subset theorem real quick. A is a subset of B. Then proposition, okay, A and proposition B. Okay. What is proposition? It's a Boolean function. Okay. Some equality. Okay. Yeah. For example, this whole thing. Here we have what x rho 3 is equal to 0. This whole thing, this equality, is this Boolean function p of x. It's a Boolean function, whether this is true or not. All right. And of course, this lowercase a is a member of uppercase A. This is a set, is a member of this set. Small b is a member of big B. Big B is a set, small b is an element of big B. Okay, so yeah, it's convoluted, right? That's why we spent a lot of time proving this subset theorem, because it's something very obvious, but it's higher order metaphysical concept. In mathematics, I first learned about this what pigeonhole principle. Pigeons, dove, bird, like homing dove, the messenger, pigeon. Pigeonhole principle, okay, it's something very obvious, but that principle, pigeonhole principle, is a very, very powerful tool in proving many very difficult theorems, conjectures, okay, so it's like this. There are 10 pigeonholes, and there are more than 10 pigeons. Each pigeonhole, this nest for this bird, it can only house one pigeon because it's so small and tight. Okay, so there are 10 pigeonholes, nests, and if there are more than 10 pigeons in this place, then there is at least one pigeonhole in in which there are more than one pigeons. Okay, let's say pigeonhole is big enough. I'm sorry, I made a mistake. Pigeonhole is big enough to house many pigeons. Okay, and there are 10 pigeonholes, pigeons' nests. Okay, it's big enough. Each pigeonhole, pigeon's nest is big enough to house multiple pigeons. Okay, but there are only 10 of them, but there are more than 10 pigeons. So, if that's the case, then there has to be at least one pigeon's nest that is housing, accommodating more than one pigeon. Okay, so that's the pigeonhole principle. Okay, yeah, it's something very obvious, very intuitive, but very plebeian, very common, very intuitive, very easy to understand, very no, very trivial. But that pigeonhole principle has been used extensively to prove some conjecture, some formula, some theorem that is not trivial at all. Okay, so that's what we are doing here. Okay, yeah, well, not exactly right, but subset theorem. I mean, just to express this, it's not that easy, right? You have Boolean function, you have this propositional logic, conditional proposition, whatever. Uh, but the concept is simple. Okay, so I'm not going to reiterate that because we spent enough time to prove this, make examples of this subset theorem. Okay, so but this does not even have much connection to periodicity though, not yet. Our goal for today is to find some connection between subset theorem and periodicity. Okay, in a lower level, not Euclidean step function. No, just modulo arithmetic, Gaussian modular number theory. Okay, so then we call row algebra. Okay, so okay. This time around, I just take a picture. I'm not gonna write this down, okay? So I just take a picture. Okay. So, well, my cell phone is out there charging, so we're gonna have to take a break. I gotta take a leak too. So take a break and grab my cell phone and take a picture of this, and we move on, okay? So, all right, take 5. Okay, we're back. You know, so far we have dealt with plenty of concrete examples. Okay, so because this is something very elementary. Okay, it's already, most of this is already known in Gaussian modular arithmetic. Okay, so I take a picture of this before I erase. Let me grab myself one. Okay, so I'm not gonna write this down, right? So let's just take a picture. Some diversification. Sometimes, yeah, I write it down and not take a picture. Sometimes I take a picture and not write it down in my notebook. Okay, cool. So, the we'll prove things, okay? Because we found that very useful, okay? So, and we'll name it as some kind of theorem. So let's say, let's just keep writing things, okay? So, how about this blue? Is this blue working well? Oh, yeah, it is. Oh, good. Very strong blue. So, let's say we have divisor, okay? So, you have some divisor, okay? M is just some number, right? And you have some remainder, all right? And then, okay? Like 3M0, right? Multiples of 3. So this number, this whole thing represents, when we divide this number by D, divisor D, then the remainder is R, alright? When R is 0, is the multiples of D, okay? And then we have multiples of D, okay? So like we call it QD, Q for quotient, just like K, okay? KMD, KMR. We know this guy rho D is equal to R. We know that, okay? Somehow we need to prove some other theorems, whatever. We need to prove that this guy is also R. Okay, so that's what we need to prove. Okay, so and this is by definition, okay? DMR is some number. When divided by D, the remainder is R. So that's by definition, okay? So, and then we need to prove this guy. Okay, so there we are, task at hand. Okay. Prove. Okay. Let's prove this. Alright, so okay. Proof. This is converting V to F. Okay. What's the difference? Yeah, the vocal cord vibration. Okay, so I forgot to say it in English. Okay, but in Korean it's a 유성음, 무성음. Okay, but English I forgot how to say it. I used to know. Okay, but they are number one. Okay, number one consonant, both of them. interchangeable. So we change colon to this close pattern. Okay, proof. Okay, prove this. Okay, here's the proof. Okay. Q D M R is let's say some number k. K times this whole thing is a divisor, right? QD plus R, all right? I'm sorry, rho D. Okay. Okay, which is equal to by this what commutative law, associative law of multiplication is equal to k times q parenthesis d plus r. Okay. We got it. We have divisor and remainder. Okay. And here it is implied that assume that we are dividing some number by divisor d and remainder is r, right? So r is between 0 inclusive and d exclusive. Okay, r is less than d. You have d and some number less than d. So therefore QD MR rho D is equal to R because this is remainder, some number less than D. So that's the proof. Okay, I'm not gonna write this down. We prove something, right? So how would we name this? Multiplication equality theorem. I'm not good at naming things, okay? So multiplication equality theorem, okay? Met. How about that? Okay, so should I write this down? Maybe I should. Maybe I take a picture too. It's kind of pretty, okay? It's blue sky, white cloud, whatever. I like the coloring of this. Okay. And I think I should write this down too. Man, it's July 4th, right? People, they go out hiking, having sex, see the firework. What the hell am I doing? Multiplication equality theorem. Okay, so the Q is, I mean, for now, yeah, we don't deal with negative numbers. Okay, so Q belongs to n 0 plus. Okay, so non-negative integers. Okay, so yeah, row algebra is it's a very powerful notational convention. It's a great tool. Okay, so because Gaussian notation we are not satisfied. Okay, so I mean he made good contribution, but we want to do better than Herr Gauss, Carl Friedrich Gauss. Okay, so okay. For example, when Q is 2 and D is 3, okay, let's say 3m2, all right, divided by 2, yeah, that's 3m2 divided by 3 is always 2, right? How about 6m2 divided by 3? Yeah, it's always 2, okay? 6m2 like what? 2, 8, 14, blah, 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 right? When it's divided by 6, it's by definition, yeah, remainder is 2. But when we divide by 3, remainder is also 2. Okay, so we formally proved it. Okay. Yeah, it's something obvious, but so yeah, it's elementary things, but we are just generalizing it, formalizing it. Okay, that's what we are doing. Okay, so okay, but no periodicity yet. The connection between periodicity and subset theorem. Maybe we'll have to get back to Euclidean numbers, Euclidean triangle, because we have dealt with enough basics, fundamentals. Okay, so now sometimes some basic formula, basic principle become visible only when we deal with some very higher level, sophisticated, challenging problem. So we have to go back and forth, higher mathematics and lower mathematics. We have to go back and forth, okay? Because some basic principle is only visible when we deal with higher, more metaphysical, more sophisticated, complicated stuff. So we have to go back and forth, higher and lower, sophisticated, complex, and simple, okay? Because I'm not quite seeing the connection, this fundamental connection between periodicity and subset theorem. Okay, so we have to go back to Euclidean triangle. Okay. So. Okay. After a break, all right. So yeah, take 5. All right. So, yeah, I got switch out these drinks and. Okay. All right, we'll be back in 5. Okay, we are back. Are you following any of this mathematical discourse? If you do, well, kudos to you. If not, that's fine. I won't say sucks to be you. Okay, you can catch up. All right. Yeah, it's not very important. Just pastime. All right. So it's not that important. Okay. So if you don't understand any of this, don't worry about it. But if you do understand what we are doing here, kudos to you. Okay. Yeah. Lucky you. All right. Otherwise, don't worry about it. Okay. It's like, you know, you go to some house party, right? They're playing these card games, right? You don't understand what they're doing. I have no big deal. It's just a game, right? It does not discredit you, okay? It does not mean you are stupid or less intelligent. No, it doesn't mean that. It just means you didn't learn the language of this game. That's all it means. It doesn't mean anything, okay? It's like you go to a foreign country as a traveler. You don't understand what they're saying. That's fine. It does not mean you're stupid or you're less intelligent or less educated. You just happen to be somebody who didn't learn the language, this particular language. That's all it is. Mathematics is just like foreign language, okay? So, or computer programming, or car mechanics, HVAC system, all these professions, okay, they have their own set of language, okay? So if you don't understand that, it does not mean you are stupid or less educated, or, because you learn something else, okay? You speak your own language in your profession and your hobby, okay? So yeah, don't feel bad. But if you understand, if you are following what we are doing here, well, kudos to you, because you have learned well. Okay, so I always wanted to say this because when I was in the Midwest in law school, so I went to Detroit, Michigan, to go to these African American dance clubs to learn their dancing. Okay, and so I met this fine African American Midwestern gentleman, a descendant of Motown in Detroit, Michigan. I told him, "Oh, I love Motown. I admire these Motown musicians, like, Smokey Robinson, who's not one of my favorite, but he's cool. Temptations and some other Marvin Gaye. Again, Marvin Gaye, he's cool, but he's not one of my favorite. Okay, so yeah, Temptations and some other bands that I forgot their names, their band names, but yeah, Motown is amazing. Okay, so that's all I can say. But back then, when I was in law school, yeah, I was able to recite all these Motown bands' names, African Americans, and he was impressed. So he told me, "You learned well. You learned very well." Okay, so yeah, and it was this moment of um, it's like Abrahamic blessing, almost. Okay, so this descendant of Motown complimenting me for having learned well, and it was a beautiful, beautiful moment. Okay, so I really appreciate that gentleman who complimented me. You learned well. And yeah, African Americans, they are awesome people. They are very beautiful and they are very profound and great sense of humor, great singers, great dancers, very talented. African Americans are like this black pearl of America. They're gemstone. Okay, they are so, African Americans are very precious asset to America. Okay, they are something else. Amazing culture, amazing people. Okay, so I just wanted to mention that. Okay, and there was something else I wanted to mention. Okay, military parade. Okay, I guess today, yeah, today is July 4th, Independence Day. So President Trump, oh yeah, Air Force, Marine, Coastal Guard, Army, Navy, yeah, you come to Washington D.C. and do this parade. I won't be doing that. What as the President of the United States in 2021, what I'll be doing is there will be no ceremony. Okay, waste of taxpayers' money. Okay, what military people will do, be it reservists, National Guards, or active duty, they will be assisting local police and local firefighters. I mean, all this Air Force, Coastal Guard, Marine, Army, Navy, they got fancy equipment, the high tech. So yeah, they'll be assisting local police, local firefighters to get rid of crimes and disaster relief, to help out people struck by wildfire or tornado or hurricane, earthquake. They'll be doing just that. Okay, so they'll be working very hard because I've been to U.S. military. I was in the army, U.S. Army. Okay, I never been to Korean Army. Okay, because I'm U.S. United States citizen. Okay, so but Korean Army is like 2 years mandatory. Okay, so U.S. Army 4 years active, 4 more years inactive reserve. When there's war, yeah, you can get called in. When I'm done with all 8 years service, when I was inactive reserve, I was never called in because there was no war. Okay, so yeah, I'm veteran, purely veteran. No more inactive reservist. Okay. So when I'm the president, yeah, they'll be helping out local community, police force, disaster relief, because they have Humvees, bulletproof, everything, and Air Force jets. What are they doing? They're just sitting there doing nothing or doing this stupid, repetitious class over and again. This pointless training over and again. They're wasting taxpayers' money. Okay, and it will be no more like that. And they won't be in stupid Washington D.C. fucking military parade, ceremonial bullshit. No, they'll be working. They'll be producing. They'll be helping out. They'll be doing something that matters. Yeah, elimination of crime, disaster relief, blah blah blah. Or how about this illegal immigration situation? Simple. We will temporarily get rid of political asylum or any kind of asylum. Period. Okay. There will be no temporarily. There will be no more political asylum. Period. Nobody will come to America. Okay. For asylum purpose. The only thing we're gonna allow is legal immigration by application. You study English, you study American history, you apply, you wait in line, and you take the test, and then we can admit you. But no more political asylum. Okay, period. Okay, all this detention facility, yeah, we'll just pass them off to Mexico. Okay, because they came through Mexico, right? We just ship them off this border line. Yeah, Mexico, you let them in so that they come to United States. Okay, so now we're gonna give them back to you. Okay, you can do whatever you want with them. We just kick them out. No more political asylum. Oh, wait for what? Some court? Political asylum petition in U.S. court? No, it won't be any of that. We just kick them out. send them all back to Mexico because that's where they came through. Okay. Yeah, Mexico. Yeah, you deal with them because you let them in, cross the border from Guatemala, from Nicaragua, whatever, El Salvador. You let them in to your country. Okay. Yeah, take them back. We don't want them. Okay. You do whatever you want with them. Okay, please. We cannot afford to think about this illegal immigrants anymore. Okay. No, we're not gonna waste any time. Okay. Yeah, we'll close down all the detention facility. We send them all back to Mexico. Okay, it will be their problem. Okay, not us, not ours. Simple solution. President Trump and you Republicans, you wanna vote for him again, right? Stupid. We'll take five, okay? Boy. I gotta start cooking my lunch. Let me grab my cell phone. Okay, so yeah, take five, okay? Okay, folks, I got some for you. Okay, this from my backyard. Okay, so it's fireweed and some grass. Okay, Alaskan grass. Uh, is there some insect flying bugs came up with it? Came with it? I don't know. Well, I kill it later. Yeah, yes, they are tall. They are taller than me. This whole grass and yeah, bouquet flower. Bouquet flower. Okay. Yeah. And the best thing, they are edible. Okay, so there's this spider. I have to kill it because in my house. It's in my house. Yeah, it didn't volunteer to come here in my house, but it just happened to be here. But it's in my house, so I have to kill this spider. Okay, so I have no problem killing bugs like this. Okay, let me see if there's any other insects. And look at it, beautiful, right? This is fireweed. Okay. Best thing, they are edible. Okay, so I'm kind of hungry, so I'm gonna eat it. Okay, so yeah. Yeah, fireweed, they're edible. Yeah, vitamins, they're good. Yeah. So that's fireweed. Okay, so Alaskan grass. Yeah, I can. It's too tough to chew or swallow, so I'll just suck on it. And they're good. Now we are left with this leftover, so I'm gonna fold it up and I'm gonna make a vodka. Okay, so okay, but they are edible. Okay, I mean they're not poisonous. Okay, so there's this flying bug came out of this guy. It's in my house, so I have to kill it. I don't entertain any insects in my house. Okay, so well, sucks to be them. I kill them. Okay, I don't allow any insects in my house. Okay, so all right, this is a good new vodka drink. So give me like 5 minutes, okay? Yeah. Well, okay. Oh boy. We have 20 minutes left. We may just continue, okay? Or not. I don't know. I'm cooking my lunch right now, but I'd rather just continue, okay? And keep on going. Alright. So today, what we have done so far today is just kind of review or revision. All right. So it's we just expressed what's been known before under the behest of Gaussian modular arithmetic. We just express it in row algebra basically. Okay. So and we proved that some stuff, and we renamed it, and we expressed in our own language of row algebra. Okay, so that's what we have done. Okay, but this yeah, this is the product. Okay, so, yeah, fireweed leaves and edible grass. Okay, so yeah, because I know them. Okay, they're in my backyard. I have many books about edible plants, poisonous plants, so I know they are not poisonous. Okay, yeah. I mean, this wild grass, I mean, at this stage in their life, they are not chewable or swallowable, but they are suckable. Okay, they don't have any poison there. Okay, so I know these plants, so I just put it in my vodka. Okay, so all right, so we're gonna construct this Euclid's triangle. Okay, do you remember how to do it? It's easy, right? Yeah, you start with one, one, and one, right? And then you start with one on the left column, and the diagonal, yeah, it's one. Okay, and now we are blank. Okay, we have just one blank. Each row is like fourth row, there's one element. Second row, two elements. Third row, three elements. Okay, and that's Euclid's triangle, just like Pascal's triangle. Well, Pascal's triangle it goes like this: one, 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 two, one, one, three, three, one. Yeah, so the number of elements in each row correspond to the index of each row. First row, one element, two elements, three elements, four elements. Okay, Pascal's triangle is like that, and uh, Euclid's triangle is like that too. Row number n has n elements. So number of elements in a row corresponds to the row index. Okay, they're equal. Okay, so yeah. Okay, so we got that. So how do you get this? Yeah, you slide it up. Okay, excluding the last element, and you add one. So two. Okay, so you have one and two flanking ones, right? And in the second column, the period is two. So it will be one, two, blah, blah, blah. Okay? But third column we haven't established yet. Okay, so, but for third column, we have third row. Is a 1, 2, 1. We get rid of the last element. Okay? And we add 1 to each. So 2 and 3. Okay, so 2, 3, because the third column, the period is 3. So 1, 2, 3, 1, 2, 3. Second column, 1, 2, 1, 2, 1, 2, 1, 2, blah, blah. Fourth column, period 1. It's just repeating 1. Okay? Okay? Now, we're on the fourth column, right? So, and we have fourth row. Fourth column is constructed by fourth row by adding ones. Okay, 2, 2, 3. Okay, 2, 2, 3. And you be now we have period 1, 2, 2, 3. In fourth column, period is 4, 1, 2, 2, 3. Then we have 1, 2, 2, 3, and on. Okay, and then we have this flanking one, right? Fifth column, fifth row, 2, 3, 4, 3. Then you have 1 here. Okay, so the fifth column, 1, 2, 3, 4, 3. 1, 2, 3, 4, 3, blah, 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 blah. Okay, so it's just go like this on and on. Okay, so that's how you construct Euclidean triangle. And I don't think this has ever been done before. Okay, I think it's brand new because I've looked through a lot of websites, mathematical journal articles. They don't have anything like this anywhere. Okay, so probably this is something brand new. Okay, so I mean there's something similar in this math world, Wolfram math world, but it doesn't quite look like this. Okay, so yeah. I mean, some this professor in mathematics in somewhere in the eastern coast, I think. Yeah, he investigated this sequence, two-dimensional sequence, but he didn't quite get to this point. I don't think anybody has been here before. Okay, I think it's brand new. Okay, this Euclidean step function, right? What division count that this professor called it in his mathematical journal article, or some tabulation of this sequence in Wolfram Math World author. Yeah, contributor wrote, but yeah, but it's not quite like this. Okay, so this kind of expression is probably brand new. Okay, that would be my best educated guess. Okay, so we should be proud and we should be grateful to God for giving this to us for the very first time in the world. Okay, so yeah, hallelujah, praise the Lord, praise Lord Jesus. Okay, so okay. So what does this number stand for? It's Euclidean step function. Okay, um, that we call E. Uh, like here, for example, we better use this from color, right? We'll use red. How is this? Yeah, this red is doing fine. Third row, right? It's like 3E, 3E1, 3E2, and 3E3. Okay? Yeah, Euclidean step function. How many Euclidean steps does it take to find GCD, greatest common divisor between 3 and 1, and 3 and 2? Let's just do this guy, okay? This is what absolute value of this equal sign, right? Just start with the 3G2, right? Is equal to, yeah, automatic promotion, right? 2G, what's the remainder? 3 divided by 2, 1, right? Okay, automatic promotion again. Automatic translation, sure. Promotion, translation. Left shift, okay? And then 2 divided by 1, what's the remainder? 0. And by definition, this guy is 1. Okay? How many steps? Equal sign, 2. So, 2, okay? Okay, so that's what it is. Okay? Just a review, something we've done long time ago. And you have 2E1, right? 2E2. You have 1E1, right? I'm just spelling it out, what this number stand for. You have 4E1, 4E2, 4E3, 4E4. Fifth row, 5E1, fourth column, 5E2, second column, 5E3, third column, 5E4, and 5E5. Okay, so that's all we need. 5 by 5 is the right isosceles triangle. Okay. Yeah, and it's also bottom up, unlike Pascal's triangle. It's top down, right? But we do more bottom up approach because we're kind of like liberal, Democratic Party kind of leftist. I have very much a lot of liberal side in me. Okay, because I love science. Okay, oh, conservative, they hate science, right? Is there global warming? I think so. I think there's global warming. I mean, Alaska, for example, ever since I got here 4 years ago, it's been getting hotter and hotter. Okay, and winter got warmer, gets warmer and warmer. I do think there's global warming, but is it anthropogenic or not? Well, that's up to the debate. Okay, and even if it's anthropogenic by fossil fuel, it's okay. Why? Just move upstate. Come to Alaska and join me. We'll move to Maine, Montana, Minnesota. Okay, no problem. Okay. Okay, so that's no problem. Right? As a joke, I'm just joking, okay? If the earth gets so hot, yeah, we'll give California, Texas, Arizona to Mexico, okay? Because it's just too hot. Yeah, take it, Mexico. So we have to move up, right? We invade Canada, okay? We annex, we invade Canada and make it into part of United States, okay? So no problem. I'm just joking. I'm just kidding. Okay, come on. Why serious all the time, man? Is it okay that I joke around a little bit? Come on, give me a break. We have 5 minutes left. This clover flower vodka is now giving up its juice. It's good. Clover flower. It's very good. So what we gotta prove next is the next step is this. Okay. Uh, we have periodicity, right? So 2e4 2e2 is equal to 2ke2. Okay, so we need to prove that shit. Okay. In general, we have what 6e3, right? So also we have 3e2. 3e2 is what? 2k plus 2q plus r e2 is same as uh, 2 plus r e2. Okay, so and 2 is a divisor, right? So dq plus r ed is same as d plus r ed. Okay, that's what we need to prove. Okay, that's the vertical periodicity. Q is from 0, 1, 2, 3, whatever, doesn't matter. Okay, so in here, D is 2, right? Q is like 0 and 1, right? When Q is 0, it's the multiples of 2. 2, 4, 6, blah, blah, blah. When, well, I mean, Q can be anything, right? But when R is 0, we have R can be 0 and 1 because divisor is 2. Okay, so when R is 0, it's like 2, 4, 6, okay? When R is 1, it's like odd number, okay? So it's like 3, 5, 7, 9, blah, 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 okay? So, and it all boils down to D plus 2 plus 0 or 2 plus 1. Okay, E2. So this is the algebraic representation of this vertical periodicity in this Euclidean triangle. And we're gonna prove this in the next episode. Okay, so we have 1 minute left. Okay, so I gotta eat my lunch and I gotta get back to work. Okay, I gotta do some work for my day job, to pay the bills. Okay, but I'm kind of loyal. Okay, I do care. Okay, the people I work for, people I work with. Okay, so we pick this up probably later this evening. Right now it's like 1 o'clock, 2 o'clock, right? Yeah, it's still pretty back there. Yeah, it's Alaskan summer in July 1st. It's our firework, okay? So, yeah, beautiful sunshine, okay? So, happy July 1st, happy Independence Day, okay? So, yeah, many Americans work during the Independence Day, including myself and some of my friends, okay? So, yeah, we are celebrating our own ways like this, okay? So, okay, all right, thank you. See you later. Happy July 4th. Bye.